Yes, the required personal protective equipment, or PPE, must still be worn within the flash protection boundary, even if the power is off in the panel below the disconnect. The line side of the disconnect remains energized, posing a risk of an electrical arc flash if disturbed. There are several ways to mitigate the need for high levels of PPE when working near energized equipment. Firstly, establish and maintain an electrically safe work condition. This involves isolating the energy source, verifying the absence of voltage, and grounding and bonding the equipment. Secondly, consider remote racking, which utilizes insulated tools or remote racking devices to operate the disconnect from outside the flash protection boundary. Thirdly, reduce the energy level by using current-limiting fuses or circuit breakers to reduce the available fault current, thereby reducing the potential arc flash hazard. Fourthly, increase the working distance by establishing a greater distance between the work area and the energized equipment. In a scenario where only the panel below the disconnect is energized, it is not safe to remove the PPE within the flash protection boundary. To avoid wearing a high level of PPE, consider these options. 1. Remotely rack out the disconnect using insulated tools or a remote racking device. 2. Install a temporary grounding barricade to isolate the energized line side from the work area. 3. Coordinate with the utility to interrupt service on the line side of the disconnect. Remember that safety should be the top priority when working with energized electrical equipment. Always consult with a qualified electrician or safety professional for specific guidance on your situation. Establishing an electrically safe work condition is crucial. This begins with a thorough understanding of the electrical system and its potential hazards. Begin by identifying all possible sources of electrical energy that could feed into the equipment you're working on. This includes not only the primary power source but also any backup generators, uninterruptible power supplies, or even interconnected circuits from other parts of the facility. Once you've identified all potential energy sources, the next step is to isolate the equipment from those sources. This typically involves opening disconnect switches, circuit breakers, or other isolating devices. However, simply opening a disconnect is not enough to guarantee an electrically safe work condition. You must also verify that the disconnect is actually working and that there is no voltage present on the equipment side of the disconnect. This verification process involves using a properly rated voltage meter to test each phase conductor to ground and phase to phase. It's important to use a meter that is designed for the voltage level you're working with and that has been properly calibrated. Before testing, always verify the meter is working correctly by testing it on a known voltage source. After verifying the absence of voltage, the next step is to ground and bond the equipment. Grounding provides a low impedance path for fault current to flow back to the source, which helps to trap protective devices and prevent electrical shock. Bonding ensures that all metal parts of the equipment are at the same potential, which reduces the risk of touch potential hazard. Grounding and bonding should be done using appropriately sized conductors and connections. The size of the grounding conductor is typically determined by the size of the overcurrent protection device in the circuit. Once the equipment is properly grounded and bonded, you can then begin work on it with a reduced risk of electrical hazards. Remote racking offers a safe alternative to manually operating disconnects, especially when working within the arc flash boundary. Arc flash is a dangerous phenomenon that can occur when there is a short circuit or fault in electrical equipment. The resulting explosion can cause severe burns, injuries, and even death. The arc flash boundary is the distance from the equipment where a person could be exposed to a dangerous level of heat from an arc flash. When working within the arc flash boundary, it's essential to wear appropriate personal protective equipment, or PPE, such as arc-rated clothing, gloves, and face shield. However, wearing PPE can be cumbersome and uncomfortable, and it doesn't eliminate the risk of injury. Remote racking allows you to operate the disconnect from outside the arc flash boundary, which significantly reduces the risk of arc flash exposure. Remote racking devices are typically designed to be used with specific types of disconnects, so it's important to choose the right device for the equipment you're working on. The devices usually consist of a handle or crank that is used to operate the disconnect from a distance. Some remote racking devices also have built-in safety features, such as interlocks and remote viewing cameras, to further enhance safety. When using a remote racking device, it's important to follow the manufacturer's instructions carefully. Before operating the disconnect, make sure that the device is properly installed and that all safety features are functioning correctly. Also, be sure to maintain a safe distance from the equipment while operating the disconnect. Reducing the available fault current is another effective way to mitigate arc flash hazards. The magnitude of an arc flash is directly related to the amount of current that flows through the arc. By reducing the available fault current, you can significantly reduce the potential for an arc flash. Current-limiting fuses and circuit breakers are designed to quickly interrupt high fault currents, which limits the amount of energy released during an arc flash. These devices work by using a special design that causes them to melt or trip very quickly when a high current flows through them. The faster the device interrupts the current, the less energy is released during the arc flash. When selecting current-limiting fuses or circuit breakers, it's important to choose devices that are properly rated for the voltage and current levels of the circuit. You should also consider the interrupting rating of the device, which is the maximum amount of current that the device can safely interrupt. The interrupting rating should be higher than the available fault current at the equipment location. Increasing the working distance is a simple but effective way to reduce arc flash exposure. The intensity of the heat from an arc flash decreases rapidly with distance. By increasing the distance between the worker and the energized equipment, you can significantly reduce the risk of burns and other injuries. The arc flash boundary is the distance from the equipment where a person could be exposed to a dangerous level of heat from an arc flash. The size of the arc flash boundary depends on several factors, including the voltage level, the available fault current, and the clearing time of the overcurrent protection device. When working near energized equipment, it's important to maintain a distance that is greater than the arc flash boundary. If it's not possible to maintain a safe distance, then you should wear appropriate personal protective equipment, or PPE, to protect yourself from the heat of the arc flash. In situations where the panel below the disconnect is de-energized but the line side remains energized, additional precautions are necessary. In this scenario, it's important to treat the entire area as if it were energized and to take steps to prevent accidental contact with the energized line side. Consider installing a temporary grounding barricade to physically isolate the energized line side from the work area. This can be done using insulated barriers, screens, or other physical barriers that are designed to prevent accidental contact with energized equipment. The barricade should be properly grounded to ensure that it is at the same potential as the surrounding equipment. Coordinating with the utility to interrupt service on the line side of the disconnect is the most effective way to eliminate the risk of arc flash. By de-energizing the line side, you can create an electrically safe work condition and eliminate the need for personal protective equipment. However, interrupting service can be disruptive and may not always be possible. Before coordinating with the utility, you should carefully consider the impact on other customers and the potential for outages. Also, be sure to follow the utility's procedures for interrupting service and to obtain any necessary permits or approvals. Regardless of the precautions you take, it's essential to remember that safety should always be the top priority when working with energized electrical equipment. Always consult with a qualified electrician or safety professional for specific guidance on your situation. They can help you to assess the risks, develop safe work procedures, and select the appropriate personal protective equipment. Furthermore, regular training and education are crucial for maintaining a safe working environment. All personnel who work with or near energized electrical equipment should receive thorough training on electrical safety principles, arc flash hazards, and safe work practices. Training should be updated regularly to reflect changes in technology and regulations. A comprehensive electrical safety program should include the following elements: written safety procedures, hazard assessments, personal protective equipment requirements, training and education, lockout-tagout procedures, and emergency response procedures. By implementing a comprehensive electrical safety program, you can significantly reduce the risk of electrical injuries and fatalities in the workplace. In addition to the specific measures outlined above, there are several other general safety precautions that should be followed when working with or near energized electrical equipment. Always use insulated tools and equipment. Insulated tools are designed to prevent electrical shock and should be used whenever working on or near energized equipment. Inspect tools regularly for damage and replace them if necessary. Avoid wearing metallic jewelry or clothing. Metallic objects can conduct electricity and increase the risk of electrical shock. Remove all metallic jewelry before working on or near energized equipment and wear non-conductive clothing. Use rubber mats or other insulating materials. Rubber mats and other insulating materials can provide an additional layer of protection against electrical shock. Place rubber mats on the floor in front of electrical equipment to insulate workers from ground. Maintain a clean and dry work area. Water and dirt can conduct electricity and increase the risk of electrical shock. Keep the work area clean and dry to minimize these risks. Use proper lighting. Adequate lighting is essential for safe work practices. Ensure that the work area is well lit to avoid accidents and injuries. Be aware of your surroundings. Pay attention to your surroundings and be aware of potential hazards. Avoid distractions and stay focused on the task at hand. Follow lockout-tagout procedures. Lockout-tagout procedures are designed to prevent accidental energization of equipment during maintenance or repair. Follow these procedures carefully to ensure that equipment is properly de-energized before work begins. Report any unsafe conditions. Report any unsafe conditions to your supervisor or safety manager immediately. Do not attempt to correct unsafe conditions yourself unless you are properly trained and authorized to do so. By following these general safety precautions, you can help to create a safer working environment for yourself and your colleagues. Remember that electrical safety is everyone's responsibility. By working together, we can prevent electrical injuries and fatalities in the workplace. Let's consider the impact of technology on electrical safety practices. Technological advancements have brought about significant improvements in electrical safety, offering enhanced protection and efficiency in various applications. Firstly, advanced monitoring systems are now available that can continuously monitor the condition of electrical equipment, detecting potential problems before they lead to failures or arc flash events. These systems use sensors to measure temperature, vibration, and other parameters, and then use sophisticated algorithms to analyze the data and identify anomalies. Secondly, smart personal protective equipment, or PPE, is being developed that incorporates sensors and communication devices. This smart PPE can monitor the wearer's exposure to heat, electricity, and other hazards, and then provide alerts if the wearer is in danger. Some smart PPE can even communicate with other devices, such as remote racking systems, to automatically shut down equipment in the event of an emergency. Thirdly, virtual reality, or VR, and augmented reality, or AR, technologies are being used to train electrical workers in safe work practices. VR simulations can create realistic scenarios that allow workers to practice working on energized equipment without the risk of injury. AR applications can provide workers with real-time information about the equipment they are working on, such as voltage levels and arc flash boundaries. Fourthly, drones are being used to inspect electrical infrastructure, such as power lines and substations. Drones can access hard-to-reach areas and provide high-resolution images and videos of the equipment. This allows inspectors to identify potential problems without having to climb poles or into confined spaces. Finally, data analytics and artificial intelligence, or AI, are being used to analyze electrical safety data and identify trends. This information can be used to improve safety procedures, target training efforts, and prevent accidents. By leveraging these technological advancements, we can further enhance electrical safety and create a safer working environment for all. It is also important to consider the role of regulatory compliance in ensuring electrical safety. Electrical safety is heavily regulated by various government agencies and industry organizations. These regulations are designed to protect workers and the public from electrical hazards. In the United States, the Occupational Safety and Health Administration, or OSHA, is the primary agency responsible for enforcing electrical safety regulations. OSHA has a number of standards that address electrical safety, including the National Electrical Code, or NEC. The NEC is a comprehensive set of rules for the safe installation and maintenance of electrical equipment. It is updated every 3 years to reflect changes in technology and best practices. In addition to OSHA and the NEC, other organizations, such as the National Fire Protection Association, or NFPA, also develop standards related to electrical safety. The NFPA 70E standard provides guidance on how to protect workers from arc flash hazards. It includes information on hazard assessments, personal protective equipment, and safe work practices. Compliance with these regulations is essential for ensuring electrical safety. Employers are responsible for providing a safe working environment for their employees and for ensuring that they are properly trained and equipped to work safely with electricity. Employees are responsible for following safe work practices and for reporting any unsafe conditions to their supervisor or safety manager. By working together, employers and employees can create a culture of safety that minimizes the risk of electrical injuries and fatalities. Continuing education is crucial to promote the safety culture. Electrical codes and standards are updated regularly, and new technologies and best practices are constantly emerging. The electrical workers need to stay up to date on these changes to ensure that they are using the safest and most effective methods. Continuing education can take many forms, including formal classroom training, online courses, workshops, and conferences. It is important to choose continuing education programs that are relevant to the type of work that you do and that are taught by qualified instructors. Many professional organizations, such as the Institute of Electrical and Electronics Engineers, or IEE, and the International Association of Electrical Inspectors, or IE, offer continuing education courses and certifications for electrical workers. By investing in continuing education, electrical workers can enhance their knowledge and skills, improve their safety performance, and advance their careers.